everyone, I'm a Huawei training teacher. In this lesson, we will learn about the trends in storage technology. Information appears in the form of data in IT systems. In this chapter, we will introduce the definitions of data and information, as well as the differences and connections. We will also introduce content related to data storage. In addition, we will introduce the history and development trends of data storage. After completing this part of the course, you will be able to understand the definitions of information and data, the concept of data storage, understand the history of data storage, and the development trends of storage products. In this unit, we will mainly introduce the first two sections, that is, data and information and data storage. At this point, you may be wondering, why do we need to understand data and information before learning about storage? This is because the value of storage lies in the ability to safely and reliably save data. The core of storage is also data, which is why we call it data storage here. Correctly understanding the meaning of data and information can help us appreciate the value of storage more deeply. So let's first take a look at what data is. The Global Network Storage Industry Association defines data as a digital representation of all things. This is because in our storage, data is represented as many zeros and ones, that is, countless binary bits. Whether it's our emails, digital music, digital videos, ebooks, or other various files we use in computers, they all appear as such binary bits in storage. This definition by SNEA means that storage can be used to describe things, but it describes things in a digital form. In computer science, data refers to symbols that can be input into a computer and processed by computer programs. Generally speaking, data is divided into three types: structured data, semi-structured data, and unstructured data. Structured data refers to data that can be represented and stored using a relational database. It usually appears in the form of a two-dimensional table, such as the tables we see in SQL Server MySQL, which are structured data. Semi-structured data, on the other hand, does not conform to the representation form of relational databases or other data tables. However, in semi-structured data, we use some segmentation semantic symbols or elements or tags to segment and layer the content. Typical examples are the languages HTML or XML that we use to write web pages or edit websites. Unstructured data, the data structure is incomplete or irregular, and there is no predefined data model to represent it. Common unstructured data includes various images, video information, and large blocks of text. In today's environment, most of the data we use and generate in our lives and work is actually unstructured. For example, all kinds of text we encounter when we browse Weibo or the various videos we watch when we browse short videos, these all belong to unstructured data. So how do we process data in our computer systems or in our IT systems? Data processing is the process of a person or machine reorganizing or reordering data. This process can increase the specific value of the data. In our course, what we are actually concerned about is the machine's processing of data. Of course, even if it is the machine's processing of data, it also needs human intervention. Data processing includes 3 steps, or the data processing cycle includes 3 stages, which are input, processing, and output. Of course, this input and output are relative to the subject of data processing, which is usually our storage or computer equipment. Input is very easy to understand. We use some input devices of the computer, such as the keyboard, to enter data, which is data input relative to the computer. After the data is input into the computer, it will be processed by human intervention or the computer itself. And this process is data processing. For example, calculating salaries from monthly clock-in records, or companies calculating our monthly income based on sales orders. This process refers to data processing. Data output refers to the process of displaying or feeding back the results of data processing. For example, in our previous example, calculating salaries from clock-in records, simply put, data is the raw material generated in the process of collection, while information is the useful information extracted from these data. We can understand that information is some useful content contained in the data. Although information and data are not exactly the same, they are also interconnected. Data becomes information after being processed to obtain useful content, and information can only be stored and transmitted in computer systems after being digitized into data. Data itself has no specific purpose. It just represents some characteristics of things or changes in things, while information is valuable and logical. The essence of data is the raw materials we collect, while the essence of information is the valuable and useful data after processing. Data does not depend on information, but information depends on data. And the storage and transmission of information also depend on data. Here are some small examples. For instance, the sales volume of concert tickets in various regions is a kind of data. But these sales volumes are useless to us. Only when we analyze them and get the sales report, knowing which concerts in certain areas are profitable and which concerts may not have an audience, can we provide valuable information for the next decision of the concert organizer. Another example is the various meteorological data and satellite image data collected by our Meteorological Bureau, which is also a kind of data. These data are useless and chaotic for ordinary people. Only after processing and analyzing these data according to certain rules and publishing the weather forecast, it is useful for ordinary people, which can help us decide whether to bring an umbrella when going out tomorrow and whether to prepare to bring an umbrella. The life cycle of information refers to the entire process, from the generation and initial storage of information to its final obsolescence, loss of function, and deletion. Information life cycle management refers to the management of the life cycle of information. Information exists in the form of data in IT systems or storage devices. The information life cycle can be divided into 6 stages, namely data creation, data protection, data access, data migration, data archiving, and data destruction. Data creation refers to the process of generating and saving data from the terminal to the storage device, while data protection and data access are processes that are highly related to our storage devices. Data protection mainly involves properly saving and protecting data through storage devices, storage software, and related methods. Data access refers to the process of people accessing data in storage devices in some way. Data migration refers to the process of moving data from one place to another, which may be due to equipment upgrades or replacements. Data archiving refers to the long-term preservation of data and the provision of access and query functions. However, these data may not frequently appear in our frequently used IT systems, so we will archive them and move them to the data storage system. After a period of time, the data loses its value for preservation. For this part of the information, we will destroy it, which is the process of completely deleting our data from the IT system. Of course, not only because of the value will some information be destroyed, but it may also be due to the requirements of certain laws and regulations for data destruction. As mentioned earlier, valuable information can be extracted from data, and in IT systems, this valuable information must also be saved and transmitted in the form of data. Therefore, data has the significance of being preserved, and the proper preservation of data is the value of data storage. Next, we are going to start understanding the protagonist of this course, data storage. Data storage, as the name suggests, is to store data in various forms on the medium. Narrowly defined storage refers to a specific device or medium, such as our common mobile hard drives or USB drives, as well as some older media, such as CDs, DVDs, and floppy disks mentioned here, and even tapes. The broad definition of storage includes more content, in addition to the storage devices we often talk about. Of course, the larger devices, such as storage arrays, it also includes storage networks and even some cards or cables used to form storage networks, as well as various storage software systems. This diagram introduces the overall architecture of the data storage system. As you can see, the bottom layer of the pyramid is storage hardware, which is divided into two categories. One is storage devices and the other is connection devices. Storage devices are devices used solely for data storage, such as disk arrays, tape libraries, virtual tape libraries, etc. While connection devices are hardware used solely to connect storage devices with other devices, such as switches, connection cables, HPA cards, etc. The middle layer is storage software. Operations such as data mirroring, replication, automatic backup, etc. can be completed through storage software. At the bottom of the pyramid is the storage solution. A storage solution can be understood as a feasible plan formed by integrating various different storage software and hardware to meet certain specific needs. Common storage solutions include disaster recovery solutions and backup solutions. Looking at the storage system from a physical structure, the bottom layer is mainly hard disks, which are connected to the backplane cards in the storage controller through various storage connectors, such as fiber optic cables or serial cables. There are computing and caching components in the controller, which can help process the data in storage. Finally, storage is connected to the storage network and switching device through the front-end board card, providing data access services for the host. Of course, there are all kinds of software inside the storage system, such as management software, application software, and NAS gateways, etc. Storage can be divided into two major categories: built-in storage and external storage, which are relative to the server or host. Built-in storage is directly connected to the host bus, including cache, memory, etc. For computers, this may also include hard drives and optical drives directly connected to the motherboard. External storage refers to independent storage devices. Based on the connection method between the storage device and the host, external storage is divided into two major categories: DAS and FAST. This is the abbreviation for direct attached storage in English. FAST is the abbreviation for fabric attached storage in English. Based on the different transmission protocols used, FAST can be divided into two major categories, namely the more frequently mentioned SAN and NAS. SAN is the English abbreviation for Storage Area Network. NAS is the English abbreviation for Network Attached Storage. In our subsequent courses, we will provide a more detailed explanation of DAS, SAN, and NAS. Data stored in storage devices also needs to be managed. The purpose of data management is to effectively utilize the data. Data management technology refers to the technology of classifying, organizing, encoding, inputting, storing, retrieving, maintaining, and outputting data. In chronological order, the storage management in computer systems has gone through 4 stages, namely the manual management stage, file system management stage, database system management stage, and big data management stage listed here. The earliest stage is the manual management stage. During the manual management stage, the commonly used storage media were cards and punch tapes, which are now rarely seen. With the development of technology, data management entered the file system management stage. In this stage, the file system began to appear, and the commonly used media were tapes and disks. With the upgrade of storage requirements, dedicated storage devices began to appear, and data management entered the traditional database system management stage. Now, data management technology has developed to the big data management stage, and distributed storage devices have begun to appear. In these years, distributed storage devices have become a very popular type of device. After understanding the definition, structure, and classification of data storage, let's understand how data storage is applied in enterprises. This picture shows how storage is used in enterprises. You can see that in the middle of the picture are various servers, including application servers, database servers, mail servers, and file servers, etc. Data from users and employees, after being processed by these servers, will be saved to storage, and then these data will be managed in storage. Based on the frequency of data access, data can be divided into frequently accessed hot data, occasionally accessed warm data, and rarely accessed cold data. Online storage is commonly used to save hot data. Nearline storage is commonly used to save warm data. And offline storage is used to save cold data. In applications, you can choose different performance storages as online storage, nearline storage, and offline storage according to the actual situation in order to reasonably plan costs while ensuring business operation. In this lesson, we briefly introduced the basic concepts of data and information, as well as the difference and connection between the two, and also introduced the basic knowledge related to data storage. That's all for this unit. Thank you for learning. See you in the next lesson.